Let's start by understanding two important braking concepts: kinetic energy and friction. Kinetic energy is the energy possessed by an object in motion. Take for example these moving blocks. Their speed and weight combined give them kinetic energy. A heavier block will possess greater kinetic energy. Similarly, a faster moving block will also possess greater kinetic energy. Now, it's important to note that energy cannot be created or destroyed. It can only be converted from one form into another. So, how do we slow our moving block once it's in motion? Well, we can convert its kinetic energy to heat using friction. But what is friction? Friction is the resistance an object experiences when one surface moves against another. As you can see, our block is now sliding along the floor, and friction is converting its kinetic energy into heat energy, slowing the block and eventually bringing it to a stop. A heavier or faster moving block possesses more kinetic energy. This means that more kinetic energy is converted to heat as friction slows the object. Now, let's take a look at a light vehicle braking system. At the front of our vehicle, we have disc brakes. They use calipers to squeeze a pair of brake pads against a brake disc, creating friction. The friction generated converts kinetic energy into heat, slowing the wheel. Some vehicles have disc brakes on both the front and rear wheels. But in our example, we have drum brakes. Drum brakes contain brake shoes. Friction is achieved by pushing these shoes against the surface of a rotating drum. Again, the friction generated converts kinetic energy into heat, slowing the wheel. Both disc brakes and drum brakes are controlled by a hydraulic system. When the brake pedal is pressed, hydraulic fluid is forced through hydraulic lines, activating the brakes. Rear brakes can also be controlled by a parking brake to hold the vehicle whilst parked and for assistance on hill starts. And that's the basics of a light vehicle braking system. Remember, vehicle brakes are safety-critical components, making a well-maintained braking system essential to all of us. Let's take a look at the components that make up a typical hydraulic braking system. We have the brake pedal, the push rod, the servo, the master cylinder, the reservoir, and hydraulic lines. The brake pedal transfers the mechanical force applied by the driver to the push rod. The push rod transfers the mechanical force applied by the brake pedal through the servo to the master cylinder. The brake servo or vacuum booster assists the driver by applying additional force to the braking system. The master cylinder converts non-hydraulic pressure from the driver's foot on the brake pedal into hydraulic pressure. When braking, pistons with seals and springs in the master cylinder create hydraulic force, which pressurizes the entire hydraulic system. Brake fluid returns to the master cylinder when pressure is released. The reservoir holds sufficient brake fluid to stop air getting into the hydraulic system. Finally, we have the hydraulic lines, which carry the brake fluid to the front and rear brakes. Now, let's take a look at the hydraulic system in action. Here we can see the wheels turning. Pressing the brake pedal extends a push rod through the brake servo and into the master cylinder. The master cylinder pressurizes the entire hydraulic system and forces brake fluid through the hydraulic lines. Releasing the brake pedal reverses the process. The hydraulic pressure on the entire brake system is reduced, allowing brake fluid to return to the master cylinder. A combination of seals in the caliper and springs in the brake drum then return the brakes to their original position, allowing the wheels to turn freely once more. Brake fluid travels through the hydraulic lines, applying pressure to the caliper or wheel cylinder pistons, which in turn create the friction force required to slow the wheels. And that's the basics of how a hydraulic brake system works. Let's take a look at the components found in a typical drum brake system. We have the back plate assembly, the brake drum, the wheel, and the wheel nuts. First, we will take a look in more detail at the brake drum and back plate assembly. Brake drums are generally made of cast iron, which conducts heat well and is slow to wear. The drum rotates on the axle and wheels, providing the friction surface when the brakes are applied. Next, we have the back plate assembly. The back plate assembly contains all the components required to operate the drum brake. Let's explore each of these components in turn. The back plate remains stationary and provides a fixed base for the other components to attach. Next, we have the brake shoes. Brake shoes consist of a steel frame fitted with friction material or brake lining. This material is bonded or riveted to the outer face of the shoe frame. There is a wheel cylinder. The wheel cylinder is connected to the hydraulic system and contains pistons which are forced outwards by hydraulic pressure when the brake pedal is pressed. Shoe retaining springs pull the brake shoe down onto the back plate, keeping it in position. A tensioning spring is fitted to the shoes. When the brake pedal is released, hydraulic pressure is reduced, allowing the tensioning spring to withdraw the wheel cylinder pistons and pull the brake shoes away from the drum. This allows the wheel to rotate freely once more. Drum brakes use a self-adjusting mechanism. The adjuster takes up excessive clearance created as the friction material on the brake shoe wears, reducing the return movement of the shoe. This effectively brings the brake shoes closer to the drum and maintains a consistent pedal feel and braking response. Finally, we have the handbrake mechanism. The handbrake cable enters the drum through the back plate and connects to the brake shoe lever arm. Cable, electronic, and hydraulic systems are found in handbrakes, but in our example, cables are used to activate the rear brakes. When the handbrake is pulled upwards, the cable is tensioned, forcing the brake shoes out against the brake drum. A ratchet in the handbrake maintains this tension until the handbrake is released. And that's the basics of a drum brake system. Let's take a look at the components found in a typical disc brake system. We have the wheel hub assembly, the brake disc, the brake caliper assembly, the wheel, and the wheel nuts. The wheel hub assembly attaches to the chassis of the vehicle and holds the brake disc and wheel. A bearing inside the wheel hub assembly allows the wheel and brake disc to rotate smoothly. This vented brake disc consists of two round metal plates, inside which there is a metal venting system. Brake pads squeeze against the disc to create friction, slowing the wheel. Friction creates high levels of heat, but the venting system reduces this heat by helping to circulate air, cooling the disc. The brake caliper assembly provides the mechanism for squeezing the brakes against the brake disc. It typically comprises of a caliper body, carrier, and brake pads. First, let's look at the caliper body. When the brake pedal is pressed, pressurized hydraulic fluid pushes out the piston. When the brake pedal is released, the piston reverts back to its original position. Externally, an outer seal and dust boot protects the piston from dust and contamination. Next, we have the carrier, which is a cast metal frame mounted to the vehicle. It holds the brake pads and caliper body. Two slider pins allow the caliper body to slide back and forth as the piston moves. Brake pads squeeze against the brake disc and produce the friction required to slow the vehicle. At the back of the brake pad there is a shim, which is designed to reduce vibration and noise. Next, we have the steel backplate, which provides the rigid base for the friction material and solid mounting to the caliper piston and carrier. An underlayer, sandwiched between the backplate and friction material, bonds the two together and acts as a thermal barrier to stop heat being transferred from the pad to the caliper. Finally, we have the friction material, which is made from a variety of compounds designed to offer a combination of stopping power, longevity, strength, and comfort. The brake pads are often held in place by springs, pins, or in our case, a clip. These accessories should always be replaced when brake pads are changed. Now, let's see how these components all work together. The brake pedal is pressed and pressurized hydraulic fluid enters the caliper body. Hydraulic pressure pushes the piston out, first forcing the inner brake pad against the inside of the brake disc. As this happens, the inner piston seal deforms. Now, the inner brake pad cannot travel any further, so hydraulic pressure forces the caliper body back along the slider pins, pulling the outer brake pad against the outside of the brake disc. When the brake pedal is released, the inner piston seal reverts to its original position, withdrawing the piston. Let's take another look at this again from above. Pressurized hydraulic fluid enters the caliper body. The piston pushes the inner brake pad against the brake disc. When the inner brake pad reaches the extent of its travel, the outer brake pad is then pulled against the brake disc, slowing the wheel. And that's the basics of a typical disc brake system.